Computational techniques. I'm going to take the topic on first module, that is which will introduce us to a new programming language, C++. C++ is a programming language that was developed by John Strostrup in 1980s. It was basically an extension of C language. It has become popular in our generation because it supports object-oriented programming, which allows programs to be structured for clarity and ease of maintenance without loss of clarity. Means programs like example like classes, structures, it all supports C++ programming. So it was popular in those days and until now. Now, in this programming language, just like we speak, we have certain alphabets and digits. Just like that, in this programming language, there are some character sets. These are the variables used in programming language. They are letters from capital A to Z and small a to Z, digits 0 to 9, special symbols, square bracket, curly braces, parenthesis, angular braces, underscore, semicolon, less than or equal to, not equal to, etc. White spaces, new line statements. White spaces are the spaces between two statements or spaces between two words. That's what they mean by white spaces or blank spaces. New line statements are statements to be in the next line in the list format. Now, besides all these characters, C++ uses 256 ASCII characters. These characters were determined by American Standard Code of Information Interchange. Now let's talk about tokens. These are also known as lexical units. These are actually the individual units of a program, that is, group of characters separated by white spaces. Each unit or each part or each group of characters, they are considered as tokens. Now there are 5 types of tokens. They are keywords, identifiers, literals or constants, punctuators or separators, operators. Now let's look into this in detail. Keywords. These are reserved words which is defined in a compiler. Compiler is basically a translator that translates a human language to binary language. These are reserved words. That means these words have only a special purpose. These are used for only special purposes. You can't read them, and they are only typed in lower cases. That's what it has a predefined meaning. That means it's only used for a special purpose. These are some of the keywords used in C++ programming language: ASM, auto, pull, break, case, catch, char, class. Now let's look into identifiers. The variables used in the programming language are, and they are declared on a set of rules. Those are called identifiers. That is the names given by the programmer on a set of rules to different parts of the program. Here, keywords are not supposed to be used because identifiers are the names that we are making, and already keywords have a special purpose, so we can't use them as identifiers. And it's a case-sensitive language. By case-sensitive language means that upper cases and lower cases are considered separately. Now these are the rules of defining identifiers. It should contain characters. It can be capital A to Z, small a to Z, 0 to 9. The first character must be letters. A to Z and small a. It should begin with a letter. It can be capital or small. Or if you can use a special symbol, that is the underscore. That's the only symbol used while defining an identifier. We cannot use any other symbol. And we cannot use white space. That means there shouldn't be space between the variables. For example, total marks, they should be typed together. You cannot have space between total and marks. And as I said before, we cannot use keywords. These are some types of valid and invalid identifiers and the reasons for why it's invalid. Let's look at the invalid ones. Invalid ones, num add. It's invalid because between num and add there's a hyphen. We can only use underscore as a special character, nothing else. The next one is this as a keyword. If it was typed in uppercase, we could have used it as an identifier, but it's typed in lowercase. And this type of variable is already used as a keyword, so we cannot use it as an identifier. The next one, it starts with a digit. We cannot start with a digit, we have to start with a letter. That's why it became invalid. Okay, next we are looking into literals or constants. These are tokens whose values does not change during the execution or running of a program. Before the program starts running or before we execute the program, we can change it, but after we start executing it, we cannot change it. They are classified into the following. They are classified into four types. Numeric constants. Numeric constants itself is classified into integer constants and real constants. Then there's Boolean constants, character constants, string literals. Now let's look in detail. Integer constants. These are also known as fixed point constants. Like the name indicates, it should not contain any decimal points. It should only contain the integer part. It can be signed or unsigned. By signed, it means that it can have a negative sign, and unsigned, it means positive. And when we write a number bigger than 1000, we usually write, for example, 5000, we write 5, comma, 000. But in programming language, we cannot use commas or blank spaces. Now they are classified into three types: decimal constants, octal constants, and hexadecimal constants. Now let's look in detail. Decimal constants. Decimal in the name itself, dec. It means it has 10 numbers, a base 10. Decimal has a base 10. If it's a decimal number in computer language, it has the base 10. So that means the sequence of numbers we can use is from 0 to 9. If suppose by mistake you declare a fraction with the decimal constant, there won't be much of a problem. The compiler will only take the integer part and ignore the fraction part. These are the valid or invalid types of decimal constants. Valid size 725 minus 27, 4.56. As I said before, the compiler will only take the integer part. Invalid case 7500, there's a comma, that's why it's invalid. We cannot use commas. The next one has a blank space, we cannot use blank space. And the next one has a dollar symbol used, we cannot use special characters. Next is octal constants. Just like the name, it has octal numbers have the base 8. That means we can use a sequence of 0 to 7 to identify it's an octal constant or not. If the number or a constant is represented with 0, it is an octal constant. These are the valid and invalid. As said before, we cannot use commas, and decimal point is actually not allowed, even though the compiler would only ignore the fraction part, but it's not allowed in integer constants. The next one is invalid because it is not a permissible digit in octal system. Next is hexadecimal constants. It has a sequence of 0 to 9 and 8 to F instead of 10 to 16. It uses letters 8 to F. And to recognize whether it's a hexadecimal constant or not, it starts with either 0 small x or 0 capital X. These are the valid and invalid constants, how it's represented. As I said before, commas are not allowed and decimal point is not allowed. Next is real or floating point constants. It's a numeric constant having a fractional part, that is actually a number with the decimal part. Here the decimal part is considered. Those numbers are called floating point constants in programming language. It can be written in fractional form as well as an exponential form. Just like integer constants, it is signed or unsigned sequence of digits. It can have positive and a negative at the prefix, and if there is no sign, it is considered as positive. Next, we are looking into Boolean literals. Boolean literals are used to represent one of the Boolean values. The Boolean values are true or false. In only, that means in memory, true means it will give the value 1 and false means it will give the value 0. Next is character constants. It is valid single character enclosed within single quotes. Any type of letter or digits enclosed in single quotes will represent a character constant. It must contain at least one single character and must be enclosed in single quotes. These are the valid and invalid character constants. The value of a single character constant has an equivalent ASCII value. Example, capital A has the ASCII value of 65. Next, we're looking at the string literals. String literals are sort in a form of comparison. If character constants are in single quotes, strings means a sequence of characters, right? It should be enclosed in double quotes. If it's enclosed in double quotes, it shows as a string literal. Not only that, in strings case, automatically a special character is added by default, that is /0, that is null value at the end. It represents the end of a string. So in memory, when we type a string, if it has say 6 values, in memory the size of the string will be stored as 7 values. That means including the null character as well. These are the valid and invalid string literals examples. Next, we are looking into non-graphic characters. It's not usually asked, but in character constants, it is the topic. It's there. These are non-printable characters. The thing is that we can type say dollar symbols, star, space, and not space, semicolon, double quotes, etc. But there are some characters, for example, space. We cannot type it directly. So to represent it in letter format, these non-graphic characters are allowed in C++. These are also known as escape sequences. They cannot be typed directly from the keyboard during execution of a program, and it is represented by a backslash. These are some of the non-graphical characters. The most commonly that we use in that we're going to see most often are /n, /t, and /0. /n, it says new line or line feed. That means if you want statements in a form of list, like line by line, we use /n, which represents the next line, and /t represents the space between two statements, horizontal tag, and /0 is the end of the string, that is non-value. Next, we are looking into punctuators. These are symbols that are used as delimiters while constructing a C++ program. They're also known as separators. Punctuators, like if you want to separate two statements, you use a comma. If you want to end the statement, you use a semicolon in C++ language. Next, we are looking into the some of the Punctuators used. Example is curly braces. The opening and closing of curly braces indicate the start and end of a block of a code. These are punctuators, that means delimiters, opening and the closing. These are sometimes used if you want to type compound statements, that means more than one statement. Parentheses, they indicate the function calls and function parameters, which we will be learning in detail further. Next is square brackets. It indicates single and multi-line result. It's when you give the maximum size to a variable. Next is a comma. Like I said before, it's used as a separator in an expression. If you want to write group of statements in one sentence, we can use a comma. And semicolon is when you want to terminate an executable statement. That means leave a full stop to it. Colon, it is used as a label in a statement. And comments, there are two types of comments: single line comments and multi-line comments. Now you want to type some lecture notes at the side when someone's explaining about a program. That time we use these comments. If it's in a one line comment, you can use single line comments, and if it's more than one, you use multi-line. Here's an example. First one is a multi-line comment. This is written by myself on Cpct. Next is a single line comment with some exact line. Next we are looking into operators. The symbols that are used to do some mathematical or logical operations are called operators, and the data items or the values of those variables that the operators act upon are called as operands. This is an example. 5 plus 6, a minus b. Plus and minus are the operator. 5 and 6 or a and b are the operands. Now operators are classified on the basis of number of operands. On the basis of number of operands, there are three types. One is unary, binary, ternary. Unary, in the name itself, it shows that it's using only one operand. In binary, it uses two operands. Ternary, it uses three operands. Now, operators are classified on the types of operations. There are 7 types. They are arithmetic operators, relational operators, logical operators, bitwise operator, assignment operators, conditional operators, and other operators. So let's look into each of it in detail. Arithmetic operators. These are operators which perform simple arithmetic operations like addition, subtraction, multiplication, division, etc. Here we use the usual calculations that we use in our day, like addition, multiplication, subtractions. They are represented as arithmetic operators, and since they use two operands, they are binary operators. The above mentioned operators are the commonly used arithmetic operations: addition, subtraction, multiplication, division. You might be new to modulus operator. It's nothing much. It's just we are using it to find the remainder after dividing two operands. That is 10 divided by 3. It will, though the quotient gives a decimal point, it definitely will there be a remainder. That to find that remainder, we are using the modulus operator. Next, we are looking into increment or decrement operators. These are also arithmetic operators. Increment means plus plus, and minus means decrement operator. For example, if you say x plus plus, it's like the same way as writing x equal to x plus 1 and x equal to x minus 1. Since it acts upon a single operand and returns a new value, it is a unary operator. Now, I've said the same example as before. Now, these operators, they can be placed either as prefix or postfix. Prefix means before the variable, postfix means after the variable. This is the prefix increment working process. Now, the question here is plus plus n1 plus n2. n1's value is 10 and n2's value is 2. Here, the speciality of prefix is that when we write plus plus n1, it immediately adds 1 to the n1 previous value and gives n1 a new value, and that new value is added to the new value of n2. n2's value is 21, so together we got the value 32. But in case of postfix, the difference is here postfix, it considers the older value. That means n1's value will be increased by 1 only after the semicolon. So here the assigned value, previously assigned value, is taken into consideration first. That is n1 equals 10, n2 since this prefix, it becomes 21 and we get s equal 31. After it, the processing reaches the semicolon and goes for the next statement, n1's value will turn to 11, but already s's value is 31, so there won't be any change. That's the difference between prefix and postfix. So to remember prefix and postfix, just remember prefix literal meaning is before, so before semicolon value will be 1, added 1. Postfix means after, so only after the semicolon the value will be incremented with 1. Here is another table showing the increment and decrement operations, prefix and postfix. As I said before, here it's prefix, so before the semicolon itself value will be increased, so a's value will become 3. Same goes for decrement, a's value will become 1 since n's value is equal to 2. A's value, but in postfix case it considers the older value, so a's value will become 2 itself. Even in the case of n minus minus, value of a is equal to 2 again. Next we are looking into relational operators. These are operators that determine the relationship between the operands. When these operations are applied, the result that we get will be a Boolean value, that is, it is representing either true or false. These are some of the relational operators used: greater than, less than, greater than or equal to, less than or equal to. Now here, these two, equal to and not equal to, they are comparison operators. A equal to B, that means they are comparing whether the value is true or not. Same in the case of A not equal to B. Since they are using two operands, relational operators are using two operands, right? So these are known as binary operators. Next is logical operators. It is used to evaluate logical and relational expressions. These logical operators act upon the operands and hence will be called as a logical expression. These are the three logical operators that we commonly use: logical and, logical or, logical not. Here two different relational expressions are checked. AND's case, both expressions should be true. Both the conditions should be true, then only the result will be true as well, else it will come as false. In memory, true is 1 and false is 0. In the case of logical or, if either one of it is true, the result becomes true. Even if it's false, the result will still be true, but if both are false, the result will be false. In NOT's case, it works only on a single expression or single operand. It simply negates or inverts the true value. For example, not 1. Not 1 is same as not true, right? That means the result will be what? False. That's what the logical not does. It just inverts the true value. If the expression is given 1 and if there is not there, the result we are going to get is 0. Now, and or both are binary operators. In NOT's case, it's only using one operand, so it's a unary operator. Now, let's look into an example. A equal to 5, B equal to 6, C equal to 7. First expression, 5 less than 6 and 6 less than 7. True. The result we got is 1, which is true. The next expression, 5 greater than 6 and 6 less than 7. One of them is false, so the result will also become 0 because we are using logical AND. In logical OR case, 5 less than 6 true or 6 greater than 7 false. But since it's logical OR, if one of them is true, the result is true. Now, A greater than B, 5 is greater than 6, true. But after that expression, there is a not, logical not. So not true means the result we are going to get is false. Wait, I'm sorry, 5 greater than 6, that's false, I'm sorry. 5 greater than 6, that means the result we are going to get is, the expression is showing false, so not false is true. Next is bitwise operators. In bitwise operators, it works on each bit of data. That means it's depending upon the binary numbers of each number given to us, and we perform bit by bit operation. Now there are 3 types: logical bitwise shift, and ones complement. Now let's look into each of it in detail. Logical bitwise operators, bitwise AND, bitwise OR, bitwise exclusive OR. It is binary XOR. These are the binary logical bitwise operators. We compare the binary values of each number. Here the bitwise AND same as logical AND itself. In XOR's case, one of them should be false if you want the result to be true. Here, if both are true and both are false, the result for both cases are 0. Now let's look into the operation. Now we have gotten a value A equal to 65, B equal to 15, and its equivalent binary values are given. Or we can find it by prime factorizing both the numbers by 2. We'll get the binary values. Here, bitwise and each 0 and each 1 is checked out, and we get a new binary value which will give us a different number as a result. Same goes for bitwise OR and also for bitwise XOR. Next is bitwise shift operators. There are 2 types: shift left and shift right. The value of left operand is moved to left by the number of bits specified by the right operand. Same case, the value of shift right, the value of left operand is moved to the right by number of bits specified by the right operand. Here, the right operand should be an unsigned integer. Here's the example. Is the number how much we have to shift. That means if it says A, shift it to left 3 times. That means from this 1, all the 4 ones should be shifted to 3 places. 1, 2, 3. So that means all these 4 ones will come here, and the zeros present here would go to the other side. Same in the case of the right. Two places this will be shifted, and we got the values. Next is bitwise one complement operators. Here it's the same as the logical NOT. It just inverts the values from ones to zeros, and zeros become one. We use the tilde or ones complement operator to recognize it. Here tilde A's value is 15 with its binary value this much, and with tilde A, each zeros and each ones gets inverted, and we get a new binary value. Next, we are looking into assignment operators. It is used to assign a value to a variable. Equal to sign is commonly used as the assignment operator in all computer programming languages. Here it copies a value to the left hand side of the variable. Since two operands are used, that means a different value is going to be overwritten on position of variable A. Means two operands are used. It is also so it's a binary operator. I would say, for example, A equal to 2, B equal to 32. If I write A equal to B, means A's value becomes 32. Here two operands are used, right? So it's a binary operator. Now there are different types of assignment operators. They are also known as shorthand assignment operators. There's addition assignment, subtraction assignment, multiplication assignment, division assignment, modular assignment. Now let's look into one of the examples. Addition assignment: A equal to 10, C is equal to A plus equal to 5. A plus equal to 5 is the same as writing A equal to A plus 5. So C's value becomes 10 plus 5, 15. Same in the case of subtraction assignment. A minus equal to 5. That's the same way as writing A equal to A minus 5. Same case of multiplication assignment. A is equal to A. A is equal to star into star equal to 5. Same way as writing A equal to A star 5. Same case of division assignment, and also same case of modulus assignment. Next is conditional operators. This is a ternary operator. Here the operators used is used as a conditional operator. The format is sorry guys, it's quite incomplete, but I'll tell you. It's condition question mark result 1 colon result 2. The question mark, the condition before the question mark has to be fulfilled. If it's fulfilled, you will get a result 1 for true value and result 2 for false value. That means it's like giving you a task. If you do this task, you will get this prize. If you don't do it, you will get a punishment. It's following that concept. This conditional operator is following that concept. And here's the example: A equal to 10, B equal to 20, 10 less than 20. True. So the result will be 10. But if it was false, if it was the other way around, if it was A greater than B, 10 greater than 20 is false, then the result would have been 20. Precedence of operators. Now, in an expression, if there are a lot of operators to be used, you don't know which one you have to execute first. So there's an order of precedence for each operators, and these operators and operands are grouped in a specific logical way for evaluation. And such a logical way of evaluation is called as association. This is the order of precedence. Operators within the parentheses are first used. Brackets are first performed first, followed by postfix increment or decrement. Next is prefix increment or decrement. In arithmetic operators, the first we use is multiplication followed by division, then modulus. After that we use addition followed by subtraction, then less than or equal, less than or equal to, greater than or equal to. After that we use equal to, then we use not equal to. In relational operators we first use logical and then we use logical or. Then we use a ternary operator, conditional operator. Then next we use the simple assignment, then we use its classification. In classification case, that's the shorthand operators or assignment operator. We first use plus equal to followed by minus equal to, then star equal to followed by divide equal to. At last we use the comma operator because it separates two relational expressions. So after the first expression is over, then only we use the comma operator to go for the next expression. This is in the order of precedence from higher to lower. So that was all for today. I hope you understand this video that I've taken about the first part. The next video I'm going to take about is data types and the structure of a C++ program. Any doubts, please comment down below. Thank you.